This is my synthesis of nitric acid. Nitric acid is a very useful chemical in the lab, however it's very hard to get a hold of, especially in the US. So today I'm going to show a way of synthesizing it by fractional distillation of concentrated sulfuric acid with sodium nitrate. So here's my distillation setup. We have a propane torch that's going to be heating a hot oil bath, which will be boiling the mixture in there. It's going to be going up the still head. I attached a thermometer using a bushing adapter, and go down and condense in my grams condenser. I'm using a vacuum takeoff adapter to vent any extra nitrogen dioxide into a sodium carbonate solution. I'm doing this because nitrogen dioxide is very nasty to inhale, and it's acidic anhydride, so the sodium carbonate solution will capture and neutralize it. And that is going into an iodine flask where I'm collecting it. Back there I have a homemade condenser pump out of a fish tank pump. I'm going to be pumping ice water through. Anyway, in a bit we'll be adding the reagents to the distillation apparatus and starting distillation. So here's a condenser filling up with ice water. And that is going to be what's cooling the nitric acid, causing it to condense and drip out of the bottom. Now the reagents have been added to the boiling flask, and the hot oil bath has been turned on. You can see that they are starting to bubble, and you can see a little bit of nitrogen dioxide in there. Also, you can see down here that there are bubbles coming out of the tube that I'm using to equalize the pressure. This means that the gases in there are expanding, and we will get back to you as soon as we see condensation at the entrance to the condenser. It's been boiling for some time, and you can now start to see condensation along the still head and on the thermometer, but not yet in the condenser. The temperature of the thermometer in the still head is reading at 76 degrees Celsius. You can start to see it drip back into the solution. It's working its way over there, though, and pretty soon we'll see a steady stream of nitric acid flowing down from the condenser. And now we can see the nitric acid coming down the condenser. So there it is. And there's our first drop of nitric acid. Alright, the distillation has now reached a stable point, which you can see condensation running down the boiling flask. The color of the nitrogen dioxide has dispersed for the most part, and we have a steady stream coming down the condenser into the iodine flask. You can see it drips about every second. Anyway, this will run for about an hour until it's done. You'll know it's done because it'll stop boiling in the boiling flask. So we'll keep you posted. We're about ready to call it done now. It has stopped bubbling in the reaction vessel. The temperature is starting to rise up to about 90 degrees Celsius. I can't turn this off. There we go. You can still see condensation. It's still dripping, so we're going to let it run for a few minutes before we stop. Distillation is now done, as evidenced by the stopping of the boiling in the reaction vessel. Some nitric acid is still condensing at the condenser, and we can see that it's still dripping into the iodine flask at a much slower rate. We're going to let the setup cool and wait for the nitric acid to complete dripping, and then we're going to be taking the apparatus apart, and we'll see the finished product. The concentrated nitric acid, we're going to observe one of its most famous reactions with copper. You can see the nitric acid fume. That's why it's very important to use it only outside or in a fume hood. The reaction goes slow at first because the nitric acid actually forms a protective layer because it's so concentrated. This effect is known as passivation. However, upon the addition of a small amount of water to dilute it, we can see the reaction proceeds vigorously. The products of the reaction are copper nitrate and nitrogen dioxide. Okay, stop the video.